How you doing, everyone? Sean O'Kane here with ChipEstimate.com and ChipEstimate TV. We're here at the 55th Design Automation Conference in San Francisco. Let me tell you a little bit about ChipEstimate.com. We're an IP portal or ecosystem comprised of over 200 of the world's largest IP suppliers and foundries, and we're all working together to help this big design community become more successful and profitable by exploring the most up-to-date silicon-proven IP available on the market today, which happens to be listed on ChipEstimate.com. And that's another reason why I want to introduce my friend here. With me today is Hugh Durdan, Vice President of Strategy and Products with eSilicon. eSilicon has their complete IP catalog listed on ChipEstimate.com as well. So that's a good start when you're ready for your next chip design. So our topic today, Hugh, is performance and configurability with eSilicon's products. So give me a broad overview of what eSilicon serves customers in the high bandwidth networking, high performance computing and artificial intelligence. AI is a big topic at DAC this year, and 5G infrastructure markets. So I understand eSilicon had made an announcement at DAC. Can you tell us a little bit about what that is?
Yeah, sure, Sean. Thanks for having me here today.
Yeah.
So today at DAC, eSilicon announced our platform of 7 nanometer design IP.
Good.
And so there's a couple of critical elements to that. First of all, what we mean by a platform is that it's a unified set of IP that all plugs and play together. eSilicon's been in the ASIC design business for over 17 years now. And what we've done in that history is use lots and lots of third-party IP to build those ASICs. Mm-hmm. And what we found is that as you go out and you acquire all those pieces of IP from all the different suppliers, and then you try to put it all together in one chip, that quite honestly it can be a nightmare. They have different metal stacks, different sign-off criteria, different operating conditions, different DFT approaches. And so what we've tried to do with our portfolio of IP is make it into a true platform where all of those dimensions are consistent amongst all the different pieces of IP. So you don't have to worry, is one piece going to work with another? How do I do testing? How do I put it in the chip? Does it use different metal layers? Does it use different transistors or whatever? It's all compatible.
Great.
So that's the first big element. The second element is those IP components.
Right.
So fundamentally it falls into 5 different categories. The newest one and the most important is we now have a high-speed SerDes developed by eSilicon, both at 56 gig and 112 gig. We have our 4th generation HBM PHY. I don't know what generation it is on TCAMs because we've been doing TCAMs for over 15 years as a company. We have a full portfolio of SRAM compilers, and we also have some special purpose IOs. So those are all the components of IP that go into that platform, targeted at the types of customers and applications that you mentioned.
Well, let's continue with that theme, because customers seem to be challenged always with TTM, time to market issues.
Absolutely, yep.
To design efficiently ahead of the competition. So why is performance and configurability important for these types of designs?
Well, a simple example is if you look at a networking chip, Ethernet has been around forever. And so there's a wide range of standards that our customers want to support, going all the way back to probably the oldest legacy is something around a 1.25 gig rate, all the way up to the latest 112 gig. And so a lot of SerDes are specialized in a fairly narrow segment of that range. And so if it's you're a customer and you're trying to develop a very flexible general purpose processor, you may have to use different pieces of IP for different interfaces. So part of what we've tried to do in our SerDes IP is make it very flexible and support a lot of these standards, so that one piece of IP can support all the applications and all the interfaces that the customer is trying to use.
Great, and I mentioned earlier that the topic of AI is very popular this year here at DAC, especially with the keynote today. was fabulous. It was absolutely amazing. So eSilicon, the 7 nanometer platform, was developed for high bandwidth networking, high performance computing, and AI applications. What is in the eSilicon 7 nanometer platform? I know you touched on a little bit at that early on.
Right, so it's again SerDes, TCAMs, memories, right. IOs, and high bandwidth memory. if you look at networking uses all of those components. Artificial intelligence uses most of those components. A very good example of that is high bandwidth memory. Neural network processing is all about accelerating the rate at which you can do the computations, and to do the computations quickly, you need data quickly. And so high bandwidth memory is an excellent way for customers to get the data on and off of their chip with very low latency at very high bandwidth. You know, we're talking multiple terabits per second of on-chip and off-chip bandwidth with that kind of interface.
Well, thanks for spending a little bit of time with us. Congratulations on the announcement.
Thanks, Sean.
And so we'll see you next time. Thank you for joining us. For Hugh Durdan, my name is Sean O'Kane. We'll be seeing you next time on Chip Estimate TV.
Oh, one more thing. You can find all about this on eSilicon.com
and
or Chip Estimate.
Thank you.
Thanks, Sean.
He's my hero.